Many students misunderstand how static friction works. A lot of textbooks state that the force of friction on a stationary object is equal to the normal force multiplied by the coefficient of static friction. But that's not quite right. The correct equation is that the force of static friction is less than or equal to the normal force times the coefficient of static friction. This means that static friction adjusts to match the applied force, up to a maximum limit. If it always equaled that maximum value, then an object could start moving without any applied force, which doesn't make sense. For example, imagine a heavy box sitting on the floor. If you push lightly, the box doesn't move because static friction exactly balances your push. But if you push harder, static friction increases until you reach the maximum possible value. Once you exceed that, the box starts sliding. Another example. Think about a book resting on a slanted desk. If the angle is small, static friction prevents it from sliding down. As you increase the angle, static friction increases to counteract gravity until it hits its limit and the book starts to slip. When solving physics problems, keep this in mind while drawing force diagrams and writing net force equations. Understanding this will help you correctly determine when an object will start to move.